You may have encountered advanced AI programs like Adobe Firefly, DALL-E, and Midjourney, all of which can transform text prompts into vivid images. These monthly subscription programs, however, are closed source, meaning that the program's source code is not available to the public. Users cannot modify, change, or copy the contents of the software source code. Therefore, you cannot modify, change, or copy the software. You're dependent on the owners of the software for updates, innovation, and changes, without voluntary contribution from the public. You're bound to the intended use of the software without much flexibility or customization. In the context of generative AI programs like Adobe Firefly, DALL-E, and Midjourney, you can generate any image you like, as long as it falls within the bounds of what's allowed. That means no copyright or not safe for work content. Only original safe for work content. You can see the limitations imposed by these closed source programs. Open source programs like ComfyUI, on the other hand, allow for users and often encourage users to modify, change, or copy the contents of the software source code. That's why they make it open source to begin with. Users typically voluntarily drive the updates, innovation, and changes within the software. This innately encourages uses of the software outside of the scope of its original intended use, and this is encouraged for the sake of the innovation of the software. In the context of generative AI, usage of open source generative AI programs is not bound to anything except for the technical limitations of the program. You can generate both original and copyrighted content, as well as not safe for work and safe for work content alike. ComfyUI is a free open source software that can do just this. It uses a node-based user interface that lets users design and execute complex Stable Diffusion pipelines using a combination of graph, node, and flowchart-based interface, ultimately so that they can generate images from text prompts without the limitations imposed by closed source projects. This means ComfyUI is more flexible and customizable, but it also requires more technical skills and resources to set up and use. Great, so what is Stable Diffusion? I'll begin with an example. You spray some cologne in a small room, and in the beginning, the scent is localized to where you sprayed it. You can't smell it on the other side of the room yet. Eventually, the fragrance spreads throughout the room evenly, in balance, without any further diffusion. That's basic diffusion. Particles moving from an area of higher concentration to one of lower concentration. What drives this diffusion are the laws and rules of physics. Now, with Stable Diffusion, it's a teeny bit different. It's still about this distribution, but in a very specific, balanced way. The key concept is the steady, predictable path of diffusion, which makes it stable, driven not by physics, but by the AI model in our ComfyUI workflow. Just as fragrance particles move from high to low concentration areas, data points in our AI model move from areas of high to low probability. We start with the simple text description like a red apple on a table. The AI probabilistically maps this description and starts creating an image starting with the most probable broader features, like an apple shape and the color red. Like particles diffusing, it moves on to the less noticeable details such as shadows, reflections, and context until it achieves a stable or complete generated image. In essence, we start with high concentration, the basic, most obvious details, and gradually diffuse or distribute the complexity of minor details throughout the image, thus generating a vivid, lifelike image from simple text input in a predictable, stable way. In our fragrance example, physics drove the diffusion of cologne. In ComfyUI, trainable models drive the generative AI that converts your text prompts into vivid images. The AI model, functioning as a rulebook or guidebook, undergoes extensive training on vast datasets, including numerous example images and their associated descriptions. This training enables the model to learn and extract patterns, forming connections like recognizing an apple and understanding how the phrase "on a table" influences the context and placement of objects. Once well trained, the model utilizes these established rules to guide the diffusion process, starting from high concentration details and gradually adding low concentration elements based on the given description. This systematic approach results in the creation of realistic images in a predictable and balanced manner. And with that, our journey begins here on this channel as we dive deeper into the world of AI. So don't go anywhere, stick around, and subscribe for future videos, because our journey into what may be society's next biggest breakthrough has only begun.